Kitty. If there are three things pop culture loved in the 2000s, it was cats, the undead, and putting the word quantum in front of things to make their sci-fi technobabble seem less insane. And what if I told you all three of these things were embodied in a thought experiment from 1935? Schrödinger's cat. You've probably heard of it, even if you don't really know why it exists, being a cat that is both alive and dead at the same time. If you're more than an hour old, you probably think, "Gee, Professor, that sure sounds like utter nonsense." Because it is. Let me explain. You see, being alive or dead isn't something you can really measure. Measuring things that are important to life, sure, but you can't isolate life as a variable. Life is a bunch of physical laws and interactions working inside a system until we can agree it is what it is. It's good enough. That thing's alive. Death, by extension, is just a consequence of something that used to be alive. A rock isn't dead because it didn't have a life to lose. Now, to understand Schrödinger's cat, we need to understand both halves of this thought experiment. What is this cat? Why does it belong to Schrödinger? What is he doing to this poor fictional animal? Did nobody vet this man? Please help. The cat is a cat. It's a little animal that lives in your house and tries to eat plastic. Its purpose here is to be something that can be alive. It's a very simple job. The Schrödinger part is more complicated. Erwin Rudolf Joseph Alexander Schrödinger, quick aside that's one hell of a name, was a pretty big deal in the field of physics in the early to mid 20th century. And when I say big, I mean he was an Oxford Fellow and corresponded with Albert Einstein, and not only won a Nobel Prize, but had a prize named after him, of which he was the first recipient. Baller move. So, he was a pretty big deal, but what did he actually do? You ever heard of quantum physics? That. He did that. He didn't introduce the idea of quantum physics, and he wasn't the first person to put some real work into it. Geez, not even close. But quantum physics before Schrödinger was kind of a mess. Schrödinger developed actual equations for understanding quantum mechanics, and closed a lot of holes in the existing theories. He was the LeBron James of quantum physics, basically. Now, the thing with quantum physics is, it's not like regular physics. In regular life, if you have all the information, you can tell exactly what's going to happen. Drop an object, you know it'll go down. Flip a coin, it can be heads or tails. With quantum physics, not so. It gets weird. Particles can only really be understood by probability, where a particle is most likely to be, or what state it's most likely to be in. You can't really eyeball quantum physics, is what I'm saying. You have to do the math to figure out a particle's fuzzy cloud of probability, and the math says a particle can be in more than one state at once, such as a neutron. It could be its adorable neutral self, or have turned into a proton, or be both at the same time. There are limits to this. Mostly, a particle can't interact with an outside system while in this state. If it does, it collapses from both back into just one. Sad to say, we can't actually see a particle like this. It's just in the math, but the math checks out. Schrödinger was aware of the wacky consequences of quantum mechanics. After all, objects are made of particles, so there's a very, very small chance that a regular, everyday object could itself exist in two states at once. So he constructed a thought experiment to illustrate the absurdity of it all. Here's the breakdown. There is a box, which is completely, perfectly sealed. Whatever is inside it cannot affect the outside world until it is opened, and vice versa. Not sound, not temperature, not gravity, nothing. Inside this box, you put a living cat. You then put a device that's capable of releasing a cloud of deadly poison on command, linked to a device that measures the decay state of a uranium atom. Finally, you put in a button that subscribes to my YouTube channel and rings that notification bell. But only if you feel like it. So if the atom decays, the device releases poison, and the cat dies. If the atom doesn't decay, the device does nothing, and the cat lives. Quantum mechanics says that since we can't observe anything inside the box, the atom will inhabit two states at the same time, and thus the cat will be both alive and dead all at once. And there you have it. A quantumly undead creature, existing not in defiance of nature, but because of it. Remember, this isn't a question of information. It's not that we don't know if the cat's alive or dead. By the laws of physics in our universe, the cat is literally both at the same time. This can be anything with two states, by the way. In their letters to each other discussing this idea, Einstein suggested a barrel of gunpowder that was exploded and not all at once. Somebody please tell Al to calm down, thank you very much. Luckily for us, and the cat, this double existence doesn't last long. When we observe it, that is, open the box, the equation collapses, and we get one or the other. So, are we ready to see what we got? Drumroll please, and... oh well, would you look at that. The cat's alive.